Hello everyone, welcome to this presentation about inequality joins in pandas with Pyjanitor, specifically efficient range joins in pandas. My name is Samuel Oranyeli. I am a data engineer and an open source contributor with contributions to Pyjanitor and PyDataTable. So, what are we going to be talking about? What are equijoins and what is the difference from non-equijoins? What are range joins? Why are they slow? What is the faster option? And what is the evidence that indeed it is a faster option? This references contains articles I used in preparing the slides, as well as the algorithms that were used for the faster option for inequality joins and range joins. So, equijoins, equality, joining two tables on columns that are equal to each other. Non-equi, not equal, joining two tables on columns that are not equal to each other, in which case it could be a greater than, a less than, or not equal to. In the SQL code above, that is an equijoin. You can see the equal sign there on the on clause. Customer ID is equal to ID. In the SQL code below, you have a non-equijoin that follows the equijoin, in which case the created at field is greater than the 1 year anniversary date. So again, equijoin, equi equals, non-equijoin, not equal, and that is any of greater than, less than, greater than or equal, less than or equal to, and not equal to. If we look at it in pandas, an equijoin is typically implemented via the merge function. In this case, it's a method. And for the non-equijoin, it's usually a post-filter operation. Pandas does not natively have any implementation for range joins within the join itself. So if you have an equijoin, that has to be implemented first, get the data frame, and then filter for the non-equijoin. Now, notice that for this case, we have an equijoin. However, there are scenarios where you will not have an equijoin. There's no common column on which to compare an equality. That becomes quite significant, and we shall see the reason. It is why you have slow range joins generally, and we shall see the reason why. So what are range joins? Range joins are typically of two kinds. They are either a point and interval join, in which case you are looking for values between two other values. The SQL code there should shed more lights. We are joining the clicks with the IP owners and saying, give me or return only the rows where destination IP is between the IP start and the IP end. So I have 2 points and I'm saying, or 2 columns, and I'm saying, search if this column is between these 2 columns. So usually you're going to be saying it's greater than one thing, it's less than another thing. The overlap join is give me the rows where these tables or these data frames overlap based on a set of conditions. The overlap join example, the SQL code should shed more lights, where it says, give me only rows where the start from the left data frame is less than or equal to the end from the right data frame, and the end column from the left data frame is greater than or equal to the start from the right data frame. So there you have it. Range joins, either a point and interval or an overlap. Note that in both of these scenarios, there is no equijoin involved. It is strictly non-equijoins. In pandas, range joins are usually computed as a Cartesian join. So you compare each row from the left with each row from the right. And that becomes quite expensive memory-wise and performance-wise as your data set increases, or the size of your data set increases. Yes, pandas has an interval index option, which is very performance, but is limited to scenarios where your intervals do not overlap. If your intervals overlap, you are restricted to using a for loop, and at that point you lose the advantage of that performance, or you lose the performance you were looking for in the interval index. So again, if your intervals do not overlap, fantastic, interval index will fit in nicely. If they do not overlap, then you're back to square one in a way. So let's have a look at an example. You've got a column, you've got a data frame from the left, a data frame from the right, and I'm saying this is a point in interval join, and I'm saying give me the rows where the pause column is between the start and the end columns. Typically in pandas, because there is no native implementation of a range join, the first thing you do is a Cartesian via the merge function, and then you do a post filter. Now you might be thinking, why can't we use an interval index? Remember I said an interval index relies on there being no overlaps for efficiency's sake. If you have a look at this, you can see the row 1, that's 5 and 11, overlaps with row 4, 7 and 25. So you've lost that advantage of the interval index in terms of efficiency. So we resort to this, the Cartesian join. Typically, this is what it does. Takes the values from the left data frame, compare it or combine it with the values from the right data frame, creates one large data frame, which is about 35 rows. So a combination of 7 and 5 rows respectively from the two data frames. And only after it has created this Cartesian, then it prunes it down to the results that we want. So again, look at that. 7 rows, 5 rows, you get 35 rows, and then you prune it down to what's 8 or 9 rows. If this was a large table, so you have 10,000 rows from the left, 10,000 rows from the right, that's like 100 million rows, and that is not good memory-wise, efficiency-wise. There must be a better way, in the words of Raymond Hettinger. And indeed, there is, with a conditional join from Pyjanitor. And this is how the API looks. The key part there is the variable arguments, which takes a tuple of columns. So left column, right column, and the comparator. You have the number option and your regular numpy. So the number uses a different algorithm altogether, and in some cases it could be faster. It does not all cases, but again, it uses a different algorithm to what exists in your numpy. As I said, the variable arguments is a left column, a right column, and a comparator. Let's just look at an example to see how it's First, you pip install Pyjanitor, you import Janitor, and this is how it looks like generally. df1 joins to df2, and then you pass the conditions. Again, look at that. That's a range join because you have a greater than, you have a less than, usually between something. So pause is greater than start, pause is less than end, and then you get your results. At its core, it's just sorting and binary search. There may be a few other things that go on in there, but at the core of the algorithms is sorting plus binary search. The core of the algorithms is reduce the number of rows that we need to compare. If at all we need to compare, let's not compare a Cartesian format. So look for the ranges of each of the values and then search within that space if at all we need to search. So if you look at that, you can see that we're not blowing up. We're just keeping everything as constricted as possible to get our results. And with this, we get significant performance compared to a Cartesian join. And because it can handle overlaps, it gives an advantage over the interval index. As I said, that's all it is, sorting plus binary search at its core. I've sold you, well, I hope I have sold you on the idea that conditional join offers more performance than your typical Cartesian join. And In a number of cases, it's comparable to interval index, especially when there are no overlaps. But let's see in terms of performance results. This is a 30,000 row data frame. And the aim here is to get overlaps. What are the overlapping events here? This is how the code looks. Again, start is just less than or equal to end is greater than or equal to start, and then you return your results. You have a multi-index if the columns from the left and the right data frames overlap. If there are no commonality, then you will get a single index column. It takes 19 seconds when we time it for this operation. This does not use number. I think when you run it with number, it's roughly the same speed. But keep an eye on that speed, 19 milliseconds on a 30,000 row. If we were to do this on a Cartesian with a Cartesian join, 30,000 rows, that's about 900 million rows. That is already crazy in and of itself. In terms of the size, we need to blow up to, we need to shrink it down to 3,000 rows. I tried this on my computer. My computer wasn't powerful enough to deal with 30,000 rows memory-wise. So I just did a sample of 5,000 and it takes 2 seconds. So think about that. 2 seconds for 5,000, which when you do a Cartesian is what? 25 million rows, compared to a 30,000 row data frame that the conditional join implemented in milliseconds, 18 milliseconds. So that's like 100 times performance improvements if you use a conditional join. Let's look at another performance option in terms of scenarios where your range join has an equi-join. Typically, when you have an equi-join in your code, it should give you more performance than just a non-equi-join. However, there is still room for optimization depending on the use case. This is a flight table. It's about 127,000 rows, and the whole aim of the range join here is get me overlaps, or where I can get layovers in terms of origins and destinations. That's just the aim. Overlaps in terms of flights. Classic pandas.merge and filter. You merge it, you create a data frame, and then you filter the data frame. It takes about 8 seconds. Not bad. Conditional join takes it a step further. It says, don't create a data frame just yet. I noticed that you have some non-equi joins in here. So give me the indices for the equi join. Thank you. Compute the non-equi joins, get the final indices, and then create the data frame. So you're delaying the purpose, or you're delaying your computation, or you're delaying the creation of the data frame for as long as possible. And then you get 1.24 seconds. So hey, about 6 times improvement. Not bad. There might be scenarios where the non-equi joins would offer more performance than the equi join. It could very well be, just as in this case, that the join keys on the equi join are heavily duplicated. In this case, that seems to be the scenario, and if we force the conditional join to run the non-equi before the equi join, we get a nice performance improvement of 329 milliseconds. So maybe another 2-3x improvements. I mentioned earlier on that it's possible that your equi join keys are heavily duplicated, and if they are, the conditional join in the number version uses a sorting plus binary search. Simple. You have less number of rows to compare altogether, and it will give you more performance. A hash join has to match each value from the left to the right. And if they're heavily duplicated, that is going to be a lot of matches, only for you to now have to prune it down. Using the number version, we get 66 milliseconds. So what's maybe another 4-5x improvements? Again, there are various options depending on your use case, depending on your data, to get improvements for your range joins. This is what I was talking about. the duplicated keys. You can see how heavily duplicated they are. 6,000 rows for some of the values there. 3,000. So if you're matching 6,000 to 6,000, you're already getting 36 million rows only for you to now prune them down. Why don't we avoid that and just use a binary search instead? Yeah, that is the end of the presentation. Again, conditional join is there. You can use it if you have ring joins or you have a combination of equi joins and non-equi joins. It will help you in terms of performance. As much as possible, it will avoid the Cartesian join. If you ever encounter issues using the conditional join, please leave a message on the Pyjanitor GitHub page and we will have a look at it. Thank you very much and enjoy the rest of the conference.